positive. This morning, I put up the take-home portion of the final. So on As You Learn, where all the exams were, the final exam take-home portion, which is due May 4th. It's worth 50 points. And I cannot take any work after May 4th at 11:59 because I need to grade. So look over the final exam, the take-home portion, and what we went over this week and see where you have questions next week. So we have class Monday and Wednesday next week. And then Thursday there's no work, and then Friday starts finals. So look over and see where you have questions. Your final exam, the in-class portion, is May 2nd. So Monday, May 2nd from 11 to 1:30. Any questions? Okay. These practice problems are under the weekly checklist. And I also put the recordings there from Monday and Wednesday, and then I'll put Friday there. And then I'll do the same thing next week for week 15. In here. The practice problems we did this week are these. So the ones you're seeing on my paper are these ones. And then the take-home ones, whichever ones you have questions on, I'll do those. I probably could, I don't know if we could get them all done or not, so. Okay. We were on exam 3, take-home portion number 4. And we're just finding the derivative. When you have a fraction, normally you think quotient rule, but when it's just one term on top and bottom, you can bring the denominator up, and then you don't have to use that quotient rule for each one of these, because you'd have to do each one separately. Remember, when we bring it up, it changes the sign on the exponent, so it would be 5x to the negative 3 plus 3x to the negative 2 minus 2x to the negative 1. And then you can take the derivative. Any questions on that part? Negative 15x, and when we subtract 1, they're the same sign, so we're actually adding them. So it's a negative 4 minus 6x to the negative 3. And then negative and negative is a positive 2x to the negative 2. Any questions on the derivative? Number 5. Okay, that is a negative. So it's a negative 2/5. plus 16x to the negative 1/4 minus x plus 3. Okay, go ahead and take the derivative. Go ahead and type in your answer for the first term. So just the derivative of the first. Remember, if you answer questions up to 5 of them, you can get 5 extra credit points on the final. We take a negative 2/5 times 35 and you get a negative 5 will divide into 35 7 times, so a negative 14x, and then subtracting 1 would be a negative 7/5. Any questions on that? A negative times a positive gives us a negative. 16 times 1/4 is 4x. Subtracting 1 would be 4/4, so negative 5/4. Any questions on the first two terms? What is the derivative of a negative x? Anyone?
Is it -1? Or is it just not? Okay.
Yeah, -1. So this is a 1. 1 times -1 is -1, and then it's going to be x to the 0. X to the 0 is just 1. And then what's the derivative of 3?
Zero.
0. So then we don't need to show that one. Any questions on that? So this just goes to 0. Oops, number 7. Find the derivative of f of x equals 2x squared minus 5 over x using the quotient rule. So remember, quotient rule is bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Well, all of these you'll be having to plug into them, so you probably want to know how to simplify them. So we'll simplify it, but on a test, if you'd rather just leave the derivative and plug into it without simplifying, it's fine. The only time you have to simplify if you're finding a critical number because you need to set it equal to 0. Bottom times, what's the derivative of the top? And you can type it into the chat so that everyone can get credit for it. Mm-hmm. 2 times 2 is 4x. Subtracting 1, it's x to the first. And the 5 goes to 0, so it's just 4x. Minus the top. And what's the derivative of the bottom? Anyone? Yes, 1. All over the bottom squared. Any questions on that part? Okay, so we have f prime of x equals 4x times x is 4x squared. Here we're distributing a -1. So -2x squared plus 5 all over x squared. Combining like terms, 2x squared plus 5 over x squared. Any questions on that? Okay, the finance problems. This would be chapter 5. Oh, and this one, I changed it a little bit because I think it's easier for you to understand effective rate if we look at different ones. And so for the interest for a loan, find the effective rate for each compounding, round to the 100th. So in the first one, we're going to do 6.5% compounded quarterly. And in this one, we're going to do 6.4% compounded continuously. Because when you're looking at different percents compounded at different amounts, it's hard to compare them. But if we find the effective rate, then we can compare them more accurately.
I'm trying to keep track of when she gets back.
Okay, so for the first one, 6.5% compounded quarterly. McLean, shut the door. I'm sorry, I have a student taking an exam and she disappeared. Anyways, so 6.5% compounded quarterly. R is your rate as a decimal. And C is the number of times it's compounded in 1 year. And formulas will be given, at least for this part, because I want to make sure you use the right formula. Most of the other ones, I don't have the formula there, but of course you can have a formula sheet. So for the first one, 6.5% compounded quarterly. 1 plus 6.5% as a decimal. Remember, just divide it by 100 or move the decimal 2 to the left. If it's compounded quarterly, how many times is that in a year? Anyone? 4. Yes. And it says to round to the 100th. Now you're rounding the percent to the 100th. So go ahead and plug it in and see what you get. Make sure you're trying these, plugging them in, because the biggest mistakes happen in plugging it into the calculator. So I'm getting this. This is the rate as a decimal. So we need to make it a percent before we round to the 100th. So it equals 6.66%. 6.5% compounded quarterly is 6.6% compounded annually. Approximate. We look at the next one, 6.4% compounded continuously. We use the formula e to the r minus 1. But everyone got this value, right? Is there any questions on it? This one, the E button is with your natural log. So wherever your natural log is on your calculator, the E is with it because they're inverses. Again, we want to write it as a decimal. So E to the 0.064 minus 1. Now, most of the time when you enter it, it gives you a caret. Then you put your 0.064, close the parenthesis and subtract 1. If you have a TI-84, it actually puts it up here, so make sure you come back down before you subtract 1. So you should get 0.06609239888. We're rounding the percent to the hundredth, so we move over to the hundredth would be here, 6.61%. So by finding the effective rate, we can actually compare the rates then. I mean, it's not too much different, but 6.5% seems higher. And actually it is even compounded quarterly. Although this is compounded continuously, it's still annually, it's still a little less. But you can better compare them. If you have different compoundings, you can't compare them. Making them annually, you can. Any questions on that? So you need to be able to find the effective rates and explain why I'm finding the effective rate or what it tells you. So it tells you the compounding annually, that way you can better compare them. Any questions on that? Second one, if you have $5,100 and put it into an account at 4.2% compounded continuously, how long will it take to double your money? Does the amount you put in the account matter, or will it always be the same amount of time doubling 4.2% compounded continuously? So compounded continuously is A equals P e to the RT. A is the amount at the end, the total amount. P is the starting amount. R is the rate. T is the number of years. And E is the function in your calculator. Any questions on the variables? So where would we plug the 5100 at? What letter do we plug 5100 in for? Yes, P. We know P is 5100. E is a function. 4.2%. That needs to be written as a decimal.
Yeah.
So 0.042. We're looking for time. How long will it take? We need A. If we're looking for how long it takes to double, if we put in 5100, what's A? $10,200. So whatever this is, this needs to be double. Any questions on that? Now we want to solve for T. So do it step by step. Just keep using your algebra skills. If you want to get E by itself, we want to get rid of the 5100. Since this is multiplied, do the opposite, divide. Any questions on that part? How do we get rid of E? Anyone?
Take the natural log.
Yes, we want to take the natural log of both sides. Because the natural log and the exponential function are inverses, you can just think of them as canceling. Any questions on that part? Okay. This is being multiplied, so we need to divide it to get rid of it. So natural log of 2, make sure you close the parenthesis. When you hit natural log, it makes a parenthesis. Close it before you divide. And I did not say what to round to, so it's up to you. So 16.5 years. Any questions on that? Does the amount you put in the account matter, or will it always be the same amount of time to double at 4.2% compounded continuously? So when we're looking for the doubling amount with the same interest rate, did it matter how much was put into the account? Anyone? It doesn't matter. No matter how much we put into this account, if we double it, we will end up with 16.5 years. If we leave it as P and put our rate 042T, whatever this is, at the end, we will have twice that. So this is your starting amount. At the end, we want to double it, so we want twice it. If we divide by the P, notice this equation is the same as what we had here. So you will always get 16.5 for that percent. Any questions on that? As long as you're using the same interest rate, it will take the same number of years to double, no matter what the total is. Any questions on that? Okay, so it doesn't matter how much you put in. Number 3. If Jack puts 300 in a simple interest rate of 8% for 5 years, and Jill puts 300 in an account at 8% compounded annually for 5 years, how much will each have at the end of the 5 years? Why are they not the same? So we'll look at Jack's first. He's putting 300 simple interest. Simple interest uses this formula. And then remember to find the total amount at the end, because they wanted to know how much we'll each have at the end. This formula only gives you the interest, so you have to add it to P to get the total amount. So we want to find I equals PRT. The variables stand for the same as before. The only one we didn't have before is I. P is your starting amount, R is your rate as a decimal, and T is the number of years. So go ahead and find out how much interest we made. When you get your answer, type it in. Yes, 120. 300 is our starting amount, our rate 8% as a decimal, and the number of years 5. We're making $120. The total in the account is A. It's your interest plus what you started with, so it's $420. So if Jack puts 300 in a simple interest, at the end of 5 years, he'll have $420. Any questions on that? Okay, Jill also puts 300 into an account at 8%, but this one's compounded annually. 5 years. Compounded amounts use this formula. A equals P times the quantity 1 plus R over C to the CT. C is the number of times it's compounded in a year. R is your rate. So all these variables we've used. We know P is the starting amount. R is our rate. C is the number of times it's compounded in a year. If it's compounded annually, how many times a year is that?
1.
Mm-hmm. So how much is in the account? Is it 420 or is there more than that? Round dollars and cents. Anytime it's money, round dollars and cents, unless my labs, sometimes they'll ask to the nearest dollar. 440. Everyone getting 440.80. You should have this, but then that 8 rounds that 9 up, so it's 80 cents. Any questions on that? So she's making 21 more dollars. Why are they not the same? Anyone? Simple interest. You make interest off of what you put in, and then you make that same amount each year. So Jack makes 8% of the $300. So $24. The next year, he still makes $24. He doesn't make interest off of the money that he made. It's the same amount each time. Where here, the first year still makes $24. But then the next year, that 24 that's in there also, so 324, they make interest off of the total. So compounded amount means the interest that you made that year, you're going to make interest off of that interest. Where simple interest, you do not. Whatever you put in to start with, you only make interest on that and nothing else. Any questions on that?
So we would just say that Jack only makes interest off of his original, like, $300.
Mm-hmm. So Jack only makes interest off of his starting amount, $300, where Jill is making interest off of the 300 plus any interest she makes each year. Mm-hmm. Yep.
Thanks. Just want to know how to word it.
Nope, that's good. Any other questions on that? Positive. That's the last one. Was there any questions on anything we went over in the last couple days? Positive. I wanted to bring the exam up. So the take-home portion of the exam is worth 50 points, 5 points for each problem, but the in-class portion is 10 points each. So it's 120 points. But this is what the this is the take-home portion. So there's one where you need to find the best fit model, linear, quadratic, and power. Then look at R squared and see which is the best. X-intercepts, Y-intercept. This one's just plugging in. Oh, remember, how do you find the profit function if you have revenue and cost? Anyone? for number 3. If you have revenue and cost, how do we find the profit function?
The revenue minus cost.
Mm-hmm. Yeah, remember profit is revenue minus, oh, it's not letting me write. That's right. So profit's revenue minus cost. How do you find the break-even quantity? Two different ways you can find it.
Set
When
profit.
you,
Sorry.
that's okay, go ahead.
Just set profit equal to 0.
Yes, one way is to set your profit equal to 0. The other way is to set revenue and cost equal. Because when you break even, you're not losing any money, but you haven't made any, so profit is 0. Or your revenue, the amount you brought in and the amount you paid off are the same. So either set revenue equal to cost or profit equal to 0. Then a piecewise function. One of the flight ones like we've done. How do you find a simple interest account? Okay, simple interest, this is I equals PRT. This one we're given the function. Remember to find critical number, you take the derivative, set it equal to 0 and solve. And you were given endpoints. So remember, you only use, to find maximum and minimum, you'll only use the critical numbers that are in your endpoints. This one's, let's see. Oh, this is one that was from earlier where you write 2 linear equations and then solve. So be careful. A lot of students start thinking it's the simple interest or compounded amount, but it's not. These are 2 linear equations. We could do one like it. Skipped one. This one, you can use your calculator in the finance or, yeah, you would want to use your finance for the calculator. That way you can find the payments, and then we can do one like that. And the last one is the scatter plot with the trend line. So that's the take-home portion. Under the weekly checklist, here's the problems that are similar. Is there any that you wanted to go over? Or is it better to look at them all first?
The one that you said, I think was number 8, where you had to do linear equations.
Okay, oh, the percent, yeah. Exam. So exam 1. Number 2. Here it is right here. Okay, so number 8 is similar to this one right here. A retired couple has 420,000 to invest. They choose one investment that is safe, which is an annual yield of 6%, and a riskier one that is 10%. How much should they invest in each fund to make 30,000 per year? So what you want to do is decide what X and Y is going to be. For instance, X is the amount put in one of the rates, which I'll do the 6%. And Y is the amount at 10%. Oh, sorry, I didn't. I started writing and I didn't bring that up. There we go. So I always label my variables first, and we're doing this one. Now, reading it over, the retired couple has 420,000 to invest. X and Y is the amount they're investing. So X plus Y needs to be the 420,000. We know what rate they're making. How much should they invest in each fund to make 30,000 in a year? So if this is what they're making each year, 6% of X and 10% of Y needs to equal the 30,000. So then we have two equations and one variable. Any questions on that part? Now you can solve this by elimination, substitution. I don't know. Would you use elimination or substitution? Remember, elimination is where we get a variable when we add down to drop out. Or substitution, we solve this for a variable and then plug it into the other one. I would probably, since it's already written, I would probably multiply this one by a negative 0.06 and then just add it to this one. So if I multiply, I'd have a negative 0.06x minus negative 0.06y equal to a negative 25,200. So then when I add those, the x's drop out. We have 0.04y equal to 4,800. Divide by the 0.04. So 120,000 they should put into the Y, 10%. So they'll deposit 120,000 at 10%. And then we know the two together have to equal the 420,000. So 300,000 at X, which is 6%. Any questions on that? Which one, Lauren, is that the one you were talking about, or did you mean a different one? Okay. Let's do the house payment one. Because we haven't done too much with the calculator. You buy a house for 120,000 and take a loan on all of it. The loan is 5.7% compounded monthly for 30 years. Find the payments, total contributed, and interest paid. So we would use our finance in our calculator. Unless it says payments at beginning or annuity due, it will always be at the end. Okay, N is the number of years times payments per year. You buy a house for 120,000 and take a loan on all of it. That means the present value of the house is $120,000. So when you have a loan, whatever the loan amount is, that's present value. The loan is 5.7%. Compounded monthly for 30 years. We put the 30 there already. Find the payments. Now, when you have payments, these two will match because every time you make a payment, it compounds. So if you're making payments, these match, which means this is 30 times 12. We don't have future value and we're looking for payments. Any questions on the values? The calculator, remember, it's under apps, finance, and TVM solver. And then we just plug our values in. 30 times 12, 5.7, 120,000, 0, and 12. Now, whichever you're looking for, you'll have a 0 there. Put your cursor there, and then you hit alpha and enter. So our payments are $696. And 48 cents. Any questions on that? Real quickly, we'll total contributed is your payments times N. So 696.48 times 30 times 12. So our $120,000 loan at the end of 30 years, we paid $250,000. To find the interest, just subtract. So you take your contribution minus your P. And pay enough to buy another house. $130,732 in interest. Any questions on that? Positive. Okay, so look over the test, see where you have questions, and we'll do more problems. Might even be able to get all of them, I'm not sure.